here we have a function whose formula is not known, but some of the values of the function is given. And actually, in real life, this is more often the case because usually you get data from experiments, and the data obtained is not for all time, but for some sampled time points. So you would end up having this kind of data, and let's say for some reason you needed the integral of this function from this time frame or from this interval. What do you do? So that's basically what we're trying to figure out. And notice that our interval is from negative 0.5 to 2. So you start from here and you end here. So that means we don't use what's outside. We only care about what's in here. And here we also have to think about how many intervals we have. From negative 0.5 to 0, we have one interval. From 0 to 0.5, that's another one, another one, another one, another one. So I have 1, 2, 3, 4, 5 intervals. So we have 5 intervals. So n is equal to 5. If you and you can actually figure out delta x by just looking at the difference, right? 0 to negative 0.5, that's 0.5 away, right? So we actually know that delta x is 0.5, but if you insist that you must use delta x equals to b minus a over n, that's possible too, because a is negative 0.5 and b is 2, so it's 2 minus negative 0.5 divided by 5. That also gives you 0.5. So either way, you get this. Now using this, how do you use the left endpoint? Well, left sum is delta x, and then you use all the values of the function at the left endpoints of each interval. So for the first interval, you use 1.3 because that's the left side. For the second interval, you use 1. For the third interval, you use 0. For the fourth interval, you use negative 0.7. For the fifth interval, you use negative 0.5, and because negative 0.3 is the right value of this last interval, this negative 0.3 doesn't get used when you're doing the left sum. Okay, hopefully that made sense. And now let's actually do the calculation. This is negative 1.2, so, and delta x is 0.5, so you have 0.5 times, if you calculate this, I think it's 1.1, so you get 0.55 as the left sum. Okay, what about the right sum? Same thing, except that you use the right endpoint. So for the first interval, you use the right endpoint, which is 1. For the second interval, you use 0. For the third interval, you use negative 0.7. For the fourth interval, you use negative 0.5. And for the fifth interval, you use negative 0.3. And in that case, delta x is 0.5, and I guess I get negative 0.5 as the sum of these values, which gives you negative 0.25. Okay, and finally, what's the trapezoidal rule? Well, trapezoidal rule uses the fact that depending on whether the function is increasing or decreasing, one of the left sum would be an underestimate or the overestimate, the other would be the opposite. So if you have one that's underestimating and another one that's overestimating, then taking the average of the two would be a better approximation, right? So that's the idea of the trapezoidal rule. So you just simply add them and divide by 2, which is 0.55 minus 0.25 over 2, which is 0.3 divided by 2, which is 0.15. So that's how you get the trapezoidal rule.